Hello. In the previous video, I explained what happens when an instrument violates the exogeneity assumption. So obviously there was a misspecification bias, and I explained that intuition. And now, as before, we are going to consider a similar case as before. We have now two variables, x1 and x2, and x1 is totally fine. x1 is exogenous, and we know that, and it is true, but x2 is endogenous. Okay, we know that. That's good. But we know that we need an instrument, so we prepared an instrument Z2. The problem is that we could not tell that the instrument was a bad instrument. So then, again, our question is, x1 is totally innocent. Still, then, will it be tortured or not? The answer is, unfortunately, beta 1 is also wrong. Let me see. The idea is pretty much the same, almost the same as what we derived earlier. So again, the problem arises because Z2, which is the excluded instrument variable, is correlated with epsilon. The covariance equals to rho. But you believe that it is 0. That is the problem. And if you believe that Z2 is uncorrelated with epsilon, then you are going to identify beta in this way. This is how you are going to identify beta. And then again, to show the misspecification bias in a general form, replace y with this linear regression equation, plug that into here. So then after expansion, we have done this many times today, then you get beta plus something, which is the misspecification bias. This misspecification bias is also 2x1 vector because there are two betas. And we can determine the bias by calculating the inverse of the 2x2 matrix. We can do that. So first, as before, everything is same as before. We will define the matrix Zx prime as in this way. So now, remember, S11 is the variance of x1, and S22 is now the covariance between Z2 and x2. And S12 is the covariance between two regressors, and S21, so now it's different. S12 and S21 are different. Previously they were the same, but now they are different. S21 is the covariance between instrument and the innocent regressor. So a little more complicated than before. And Z epsilon, the first element of Z is x1, which is doing well, but the second guy causes the problem. And do the math. I skipped one step online, and if you take the inverse matrix of this guy and multiply this guy, you will get the misspecification bias in this form. So remember, now let's read it. So first, the denominator is non-zero. And I think we cannot determine the sign of this guy. So in this case, we cannot tell what is the sign of the misspecification bias. I'm not so sure. I have not thought about that when I write this lecture note. So I think I use the lecture note that I write last year. And I don't know, maybe it's not determined. So if you don't think so, let me know. So we don't care about the sign right now. anyhow, like beta 2 it has this much misspecification bias. Remember, S11 is a variance of X1, therefore it is always non-zero as long as rho is non-zero. So the beta 2 is certainly biased whenever whenever the instrument is endogenous. So which is obvious, intuitive. But now think about the first guy, and as before, it depends on S12, which is this one. It depends on the covariance of X1 and X2. Interestingly, it is not the covariance between the regressor and the instrument. It is the covariance between two regressors, right? So that's it's quite confusing what's more important, but the answer is this one. So that's what we derived mathematically. So anyhow, beta 1 is biased. And for this to be unbiased, the only possibility is that X1 and X2 must be uncorrelated. So the uncorrelatedness is an important condition for beta 1 to be unbiased, but it's rare. That kind of case is rare. In almost always, regressors are correlated, so you have to assume that beta 1 is biased. So the answer is, the conclusion is clear. When your instrument has some problem, then everything in your analysis will be wrong. So be careful. Okay, I think I'm going to stop the video here, and I will finish this chapter in the next one, which will be maybe short. Thank you for watching.